Have you ever seen a robot in a movie and wondered if they could be real? Machines that can walk, talk, and think, just like us. Instead of walking down the street, you are more likely to find them in a giant factory, assembling a car with perfect precision. You might find them deep underground in a mine, exploring distant planets, or even assisting surgeons in an operating room. They all look so different. A robotic arm, a rover on Mars, and a small vacuum cleaner in your house. So what makes a machine a robot, and what is the science that brings them to life? This is the world of robotics. To understand robotics, you just need to remember three simple words: sense, think, and act. Every single robot, no matter how simple or complex, is designed to do these three things. Let's break down what that means. It all starts with sensing the world. Just like you have 5 senses to understand your surroundings, a robot has sensors. A robot's eyes might be a camera, or even advanced laser scanners that can see in 3D. Its ears could be a microphone, listening for a specific command or a strange noise. Robots can also have a sense of touch, using pressure sensors to know how hard they are gripping an object. They can have sensors for temperature, for motion, and for location, like the GPS in your phone. Sensing is how the robot gathers information or data about the world around it. But data alone is not enough. The robot needs to do something with that information. That brings us to the second step: think. The brain of a robot is a computer, often called a controller or a processor. This computer runs a program, which is a set of instructions written by engineers in a language called code. You can think of the code as a recipe. The sensors provide the ingredients, which is the data. The computer follows the recipe step by step to decide what to do with those ingredients. If the camera sensor sees a red ball, the code might say, "The object is red. My next instruction is to pick it up." If its pressure sensor feels that it is gripping an egg too hard, its code might say, "Reduce pressure immediately to avoid breaking the egg." This thinking part is where the robot processes information and makes a decision. But a decision is useless if you cannot do anything about it. This is where our final step comes in: act. Acting is how a robot affects the physical world. It's how it moves and performs a task. Robots act using components called actuators. Think of actuators as the robot's muscles. They convert electrical energy into physical motion. The most common actuators are motors that spin wheels, turn gears, and move robotic arms. Other actuators can be grippers that open and close like a hand, or pistons that push and pull. The robot's computer brain sends signals to these actuators, telling them exactly how and when to move. So let's put it all together. Imagine a robotic arm in a car factory. First, it uses its camera sensor to see a car door on a conveyor belt. That's sense. Its computer brain processes the image, identifies the door, and calculates its exact position. That's think. The brain then sends instructions to the motors in its arm. That's act. The arm moves perfectly, picks up the heavy door, and places it onto the car's frame with incredible accuracy. Sense, think, act. Over and over again, thousands of times a day, without ever getting tired. But what about robots that seem to learn? Like a robotic vacuum that gets better at cleaning your room over time. This is where robotics meets another exciting field: artificial intelligence, or AI. A simple robot just follows its pre-written instructions. If something unexpected happens, it might get stuck. A robot with AI can learn from its experiences. The first time the robotic vacuum cleans your room, it might bump into furniture. Its sensors record the location of every obstacle. It uses this new data to update its own map, its own thinking about the room. The next time, it remembers where the chair is and navigates around it. It learned and adapted. This is how machines are learning to do more and more complex jobs. So robotics is not just about building cool-looking machines. It is a combination of many different fields. It's mechanical engineering to build the body, electrical engineering for the circuits, and computer science to write the code for its brain. Robotics is the science of creating a machine that can understand its environment and intelligently perform a task in the real world. Every robot you see is an answer to a problem. How can we build things faster? How can we explore places too dangerous for humans? How can we make life easier? This technology is changing our world, from manufacturing and medicine to agriculture and exploration. They are tools that handle the tasks that are too dangerous, too difficult, or too repetitive for people to do. This allows us to focus on creativity, innovation, and solving even bigger problems. Robotics is not about building a world for machines. It is about building a better world for all of us.